Hi guys, welcome to my YouTube video. My name is Henry and I'm an A-level student doing maths, physics, chemistry and further maths. So today I'm going to be doing Cambridge IGCSE multiple choice paper 1 from May June series 2024. So without further ado, let's do the questions. So question 1. Student wishes to find the volume of a small irregular shaped stone, a ruler and measuring cylinder. Which apparatus is needed? None of them are needed. Wait, no, the measuring cylinder only. We don't need the ruler, but the measuring cylinder is needed. A car travels along a straight road with constant speed. What describes the speed time graph? Okay, speed, time. It's saying it goes with constant speed, so speed is the same, so it's going to be a horizontal line. Question 3. 4 objects are moving along a straight line and the distance of each object from a fixed point of the line is plotted against time. Which object is decelerating? So as you can see, whilst the distance increases, the time increases. So the distance is equal to velocity over time. So the velocity is constant at this point. Sorry, velocity is equal to v is equal to distance over time. And if you look for the gradient, it's going to equal to a constant. So it's not accelerating. And look at this side. This is accelerating, it's not decelerating, because the distance is increasing whilst the time is stagnant at a point, so it's accelerating. But this one, as you go, it flatlines, so it means it's going to travel less, meaning the speed is reducing. Since speed is the gradient of this is decelerating. So I'll say it's C. Let's just take T. Distance is decreasing. But I say distance, not displacement. So it can't be 0. If you say displacement, maybe, but that eliminates the answer. Question 4. An object is taken from the Earth to the Moon. Acceleration of freefall is 9.8 on Earth and 1.6 on the Moon. Which row describes the mass and the weight of the object on the Moon compared to the Earth? So our equation F is equal to ma. Let's go. And m is constant, meaning F is inversely proportional to A, where A is equal to G and F is equal to W. So W is inversely proportional to G. That means if G is low, the weight is low and M is always constant. So let's see, the M is always constant. These are the two solutions we're looking for. Which one? So which row describes the mass or the weight of the object on the Moon? So the Moon, G goes down. G is less than this G, so meaning our W is supposed to be less. So we have to say it's less than the Earth. Go with D. Question 5. The diagram shows some liquid in a measuring cylinder and the mass is 16 grams. So what's the density? So density is equal to mass over volume. The mass is equal to 16. And then the volume of the liquid is equal to 20. So 16 over 20, 4 into that is 4 into that is 5, so 0.8 grams per centimeter cubed. Go with A. A single force acts upon an object and the volume of the object does not change. Which statement is correct? So a single force acts on an object and the volume doesn't change. So which statement is correct? The density of an object changes. Density doesn't change. The velocity of an object changes. We'll sideline this one. The mass of an object changes. The mass doesn't change. And then the weight of the force changes. A force acts on an object and the volume doesn't change. So if this force is equal to ma. So if you have resultant force, that means you have acceleration. So wait, I would gladly eliminate this one and go with B. Because the resultant force is equal to mass times acceleration, and if there's a resultant force, that means the body is accelerating, and that means the velocity of an object changes. Question 7. 4 electric motors do the same quantity of work when they lift a weight of 10 newtons through the same distance. The times taken by each motor to lift are shown. What is the time taken with the one with the most power? So remember, power is equal to energy transferred over T, and remember, energy transferred is equal to force times distance. So power is equal to force times distance over T, and they all have to lift the same weight F. So F is a constant, we don't need F. The same distance, so distance is a constant also. So P is inversely proportional, power is inversely proportional to time, meaning the less time you have, the more power. So we're looking for the least amount of time over here. So that's going to be A. Question 10. Which rho describes how pressure beneath the surface of a liquid depends on the depth below the surface and on the density of a liquid? Which rho describes how the pressure beneath the surface of a liquid depends on the depth below the surface and on the density of the liquid? Below the surface of a liquid. So we know pressure, hydrostatic pressure is equal to rho G H. H is depth, then rho is density, G is gravity. Gravity is a constant, so pressure is inversely proportional to G and H. So depth below the surface, beneath the surface of a liquid. How the pressure beneath the surface of a liquid depends on the depth below the surface. Beneath the surface of a liquid depends on the depth below the surface and on the density. I'll hold this one right now. But honestly, I feel like if rho is inversely proportional to GH, but it's saying beneath the surface of a liquid, I'll just skip the wording. Go on to 9. In which process does a gas turn into a liquid? So gas to liquid is condensation, and then liquid to solid is freezing. So condensation and freezing. But from gas to solid and solid to gas, it's sublimation. So does gas turn to liquid? That's going to be condensation. Question 10. A pollen grain in a beaker of still water is viewed through a microscope. Which diagram shows the most likely movement of the pollen grain? It's going to be A, because it's Brownian motion. It's not Brownian motion of the particle, but it's the Brownian motion of the water pushing against the particle. So the water particles are going to constantly move around spontaneously, bombarding the particles and causing that random movement. So if you see a question that asks you to describe the motion of a pollen grain, don't describe it and saying the pollen grain is random. Say that the water particles, or if it's smoke, it's the air particles, move randomly and they collide with the pollen grains and cause it to move with Brownian motion. Just a heads up for paper 2. So what's the relationship between the temperatures in degrees and the ones in Kelvin? So theta in Kelvin is equal to temperature. Wait, no. T is in Kelvin. And theta is in degrees. So that means T is equal to theta plus 273. Because I know 0 degrees is equal to 273. That means to make theta the subject of the formula, you get theta is equal to T minus 273. And which one's the solution? What's this one? In a famous experiment, the scientists showed that when water in an insulated tub is stirred, its temperature increases. What can be concluded from this experiment? So, when water in an insulated tub is stirred, its temperature increases. Temperature is a store of energy. Hold up. water absorbs heat from surroundings? It can't be because it's insulated, so it can't absorb from the surroundings. Work done by stirring increases the internal energy of the water. This is plausible. And then energy is not conserved. Energy is always conserved. Temperature is a store of energy. No, temperature is not a store of energy. So our answer has to be C. Solids expand when heated and contract when cooled. In which example is there a useful application for expansion and not an unwanted effect? We hate expansion in bridges, so it can't be. In railway lines, it causes buckling. In telephone cables, we don't want that again. And then in thermostats, we do want that. Okay, a rod is made of half aluminum and half glass. A pin is attached to each end of the rod by max, and the rod is heated at the center, and the peel falls up when the wax melts. So when you apply heat and a pin falls up where the wax falls, what are we trying to say? I think we're trying to prove conduction. So where the pin falls off the first means it's a better conductor. So now we have to prove which one is a better conductor, aluminum or glass. But remember that most metals, if not all metals, are good conductors. So before I even read the question, I know that aluminum is going to be a better conductor than glass. So let's read the question. Which statement is correct? The pin P falls off first because aluminum is a better thermal conductor than glass. Exactly what I said. So this has to be the solution. But we'll just read everything else. Pin P falls off because aluminum is a worse thermal conductor than glass. This is wrong. Pin Q, all these two are wrong, so we're not going to read those. Question 15. In countries where it's usually hot, houses are often painted white. What is the reason? We know that white reflects light. So in most houses, when they're painted white, they're trying to reflect the sun's rays. So the rays don't go into the house and heat the houses. From the solutions, white surfaces are good reflectors of infrared radiation. White surfaces are good conductors. Nope. White surfaces are good absorbers. Nope. White surfaces are good emitters of infrared radiation. So it has to be this one. What is the name of the distance from one crest in a transverse wave to the next crest? This is a period. And then from here to here, this is the amplitude. And then again, why am I saying period? It's the wavelength. Why am I saying period is the wavelength? And then the period is the time it takes between the start of an oscillation to the end of a complete oscillation. So sorry. I was thinking of something else. Don't listen to me. This is the wavelength.